Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman and this is a very special episode that takes a deep dive into the complex subject of power electronics. The APC recently released a new value chain map to break down the mystery of semiconductor manufacturing in the UK, which is available now to download. We held a live panel discussion hosted by journalist David James, featuring McLaren Applied, Clas-SiC Wafer Fab and Exawatt to explain the finer details. This you will want to stick around for. But before you hear the full discussion, here is CEO Ian Constance to quickly summarise what are power electronics and why they are important for the UK's automotive sector.
Power electronics are an essential part of electric vehicle technology. I think everybody understands a battery and what a motor is, but the less well-known bit is the power electronics that sit between the battery and the motor and put the current into the motor in a way that makes it drive. They also help charge the batteries through the battery charging mechanisms. They're a high-value, high-tech bit of kit that the UK has long had a capability and been developing the basis of the technology and some of the high power system elements in power electronics. Because they've got so much value, these power electronics, as part of the electric vehicle system, as we see this transition to EVs, value in the amount of batteries we use, the motors we use, and the power electronics are all going to go up exponentially over the next few years. And for us to have a full value chain within this space, then this is a massive opportunity for the UK automotive industry and the supply base.
That was APC CEO Ian Constance, and now here's Bhavik Shah, a technology trends consultant, who will give you a short explainer of the report and value chain we've created and what you can expect from it.
Hi, I'm Bhavik. The technology trends team at the Advanced Propulsion Centre have released the first of its kind power electronics value chain, describing the end-to-end manufacturing steps in making electric drive power electronics. We've done this in collaboration with our sister organizations across industry, academia, and R&D organizations that are all experts in power electronics. The value chain charts the key steps in preparing manufacturing chips. That goes all the way from wafers to die production. We then go on to power modules and the discrete package devices that then find themselves into fully integrated power systems. That's the inverter, converter, and the onboard charger. And what you'll also find on the value chain is the three main semiconductor routes as well, including the journey of silicon carbide. Together with the Insight report that we're releasing as well, we want to facilitate a much more richer conversation between industry, investors, and government on strengthening and building the UK's compound semiconductor supply chain. So please feel free to download, share the reports, and get involved. Thank you.
Thanks, Bhavik. Now, on to the full discussion with our expert panel, which took place in front of a small live studio audience in the APC's showcase venue. We hope you find it interesting.
Hello and welcome to this special event all about automotive power electronics, brought to you by the Advanced Propulsion Centre. As we're all aware, there's a seismic shift happening in the automotive sector as we move rapidly from fossil fuels to net zero transportation. And it's a very difficult time to make good business decisions because the technology is advancing faster than the supply chains can keep up. It's very difficult and risky to take on a new technology if there isn't already a supply chain to deliver it at the price and scale you need. And it's also risky to stick with established supply chains if a new technology is just about to render them obsolete. So one organisation that's helping businesses in the sector make good decisions is the Advanced Propulsion Centre. And we're here today to talk about their latest research in power electronics, where they've mapped the entire supply and value chains. Our intent is to open the dialogue that will help us all make the decisions we're going to need to build a world-leading automotive power electronics industry here in the United Kingdom. With me to discuss this, we've assembled a team of experts. We've got Steve Lambert from McLaren Applied, Head of Electrification, Ray Heinzman, Managing Director of Clas-SiC Wafer Fab, Adam Dawson from Exawatt, who specialise in power electronics and battery technology consultancy, and Bhavik Shah, who's the author of this report for the Advanced Propulsion Centre into Supply Chains for Automotive Power Electronics. So Bhavik, let's start with yourself. What are power electronics in terms of the automotive industry, and why are they important?
I think power electronics has started surfacing in everyone's language over the last 18 months for the wrong reasons, which is the chip shortages, David, right? So what I want to clarify is actually power electronics is ubiquitous. It's underneath every electric vehicle, and we kind of forget it. So without it, you can't get a battery to do what it needs to do. You can't get electric motor to run. That's how fundamental it is. So you notice when a shortage comes around. So effectively, to go from a battery to a motor, it needs to go from a DC current into an AC current, and you need an inverter for that. You want to put auxiliary power through your system, you need a converter to that, which takes higher voltage and puts it down to the right levels all across the vehicle, which is an electrified powertrain. And if you're plugging it in your car, whatever you do, and you've got an AC socket coming in, you need an onboard charger, and that takes your AC current from whatever socket you've got in your charge station and puts it onto the battery, which is DC. So imagine all of this AC, DC step down aspect is all part of something that happens in the background, and we forget about it, and those are power electronics all through the electric vehicle system. But forgive me, what I was going to mention was power electronics are on every vehicle, whether it's electric or not electric, is what I was going to mention. So you've got semiconductors on every ICE vehicle out there. That's not the same as the power electronics we're referring to on inverters, converters, and onboard chargers. So when you have semiconductors, they will be on your rear view mirror cameras, on your boot locks, they'll be on your power steering, they'll be in the infotainment. Even those supply chains are struggling to keep up with demand.
For the energy transition that we're looking at, it is fundamental for hybrid vehicles, battery electric vehicles, and hydrogen fuel cell vehicles. So why were you developing new work in this area? Why did you do the work that you've done? What's the issue you're trying to address?
So this is it. I think we don't understand power electronics well enough in the industry, David. You're absolutely right. And one of the fundamental things is language, processes, understanding where the value is within it. So if we can, what we did at the Advanced Propulsion Centre is draw up a value chain map, right? It takes you very simply through the whole process, but makes the language very accessible for investors, for government, for industry to start to collaborate together. So where a document can say, here's where the journey of a wafer starts, for example. Here's where the wafer can be layered into an epitaxy wafer, which is still a wafer. And then the wafer then, epitaxy wafer then gets fabricated die put on it, which again, amazing work at Clas-SiC as well do. That's all processes and language that we are not very familiar with. And so we brought this document out to bring that out. What we can then do is talk about the power modules. We can talk about the inverters, which again is where McLaren Applied do this. So one document explains that very simply, and then we add more insights on top of it.
So on the supply chain map, if you look at that, then you can see that it starts on the left-hand side with the wafers, and then it builds up until you get inverters or converters, chargers, etc. But none of this can be done without the supply chain. Did you get a sense of how much of the supply chain's currently in the UK?
Yeah, so what we did is, so firstly was the understand the landscape, terminology, technology, which is what the value chain does. Then once you understand the big buckets, wafers, epi-wafers, die, power modules or discrete package devices, and you get to the inverter systems as well. You can map out the kind of companies involved in the UK for this and start to understand where is the supply chain getting frustrated? What is the cross communication between stuff that's not happening? So APC already does funded projects looking at end-to-end supply chains like the Escape project, which is what we start to see is really essential to start talking it through. But are we making them at the volumes that we need is probably the place where I think a lot more action needs to be done. Yeah.
Adam, can you give us a sense of the macro environment that this is all happening within, the wider supply chain perhaps?
Yeah, well, we've mentioned kind of the energy transition, but that's very much driving all of this through. Globally, we need to transition away from fossil fuels and decarbonise. Electrification is the biggest and easiest way to do that in most sectors. And so, yeah, we're seeing electrification across the board driving that, and anything to do with electrification requires power electronics. So, for example, already today, the global power electronics industry is worth about $30 billion per year globally, of which kind of automotive powertrains is maybe about 10% of that. But that's based on only electric vehicle production around a few million vehicles per year. We see that growing to kind of 50 million vehicles per year and beyond, to the full market electrifying going forward. So that's really going to drive growth in electrification and the power electronics requirements going forward.
Where are manufacturers getting their components, whether it be the wafers, or where's the centre of mass for power electronics? Is it scattered around the globe, or are there hubs?
Yeah, so there's lots of different technologies that are potentially coming to fore with this as well. But at the moment, everybody's scraping together to really invest in this and meet that demand. But right now it's kind of dominated by particularly kind of Western manufacturers in Europe and the US, also kind of Japan, South Korea. So there's a lot of existing larger global companies in the kind of silicon side of things and the existing incumbent silicon technologies. When it comes to other newer technologies that might enter into these markets, that's where it's still growing, and we're still seeing that develop. But right now, for example, silicon carbide as a technology that we're looking at, particularly in the automotive sector, that's currently dominated by US, European and Japanese companies, at least at the larger scale today.
Okay, so if I'm an OEM looking to build maybe electric vehicles or hybrid vehicles, what are the big threats that I'm facing as a manufacturer?
One of the biggest things really at the moment is actually just getting hold of some of these materials and these components. There are shortages in general in the semiconductor industry, or have been well publicised. But as we're looking into particularly vehicle electrification and these new technologies we really think are going to kind of make a difference and come to dominate the power electronics technologies going forward, there are still big bottlenecks in those supply chains in terms of ramping up capacity globally, particularly at the materials level. But at all stages, it's not easy to ramp this up quickly. And so there's some big challenges there in terms of getting hold of the right devices at the right prices.
So it sounds like it's early days for everybody. It's a level-ish playing field for advanced economies like the US, Europe, Japan. But Steve, you're involved in the manufacture of power modules. You almost the end product as far as power electronics is concerned. Where do you think the UK's got strengths?
That's a good question. So I think we have a lot of strengths in design. So certainly designing these components, designing the technology that goes into it, but less so in making that happen. So let's say the manufacturing and the supply chain that goes around that. We have pockets of strengths, but not a fully complete supply chain that's really going to service that market. We're definitely seeing pull from the OEMs. As a tier one, we see a lot of pull from the OEMs for this technology. Everybody wants something more efficient. Efficiency is going to be the next big currency, and so getting a more efficient drivetrain is really important. So we can do the design. We have opportunities around niche volumes, mid-market volumes, but we need to get the manufacturing capability, the supply chain capability in place to support those types of volumes.
Does that mean that you've got a sense the industry will be sitting in a particular segment? Or it doesn't sound like the UK's really set to compete in the mass market. We're not going to do this for electric scooters and bikes.
No, I think it's where we can differentiate is what we've got to work out. So certainly the higher performance end of the market, where we see 800 volt and silicon carbide potentially becoming dominant, is where we can start to compete. Where you might need a differentiated drivetrain in automotive, for example, it's that differentiation, slightly more niche, but still high enough volumes that you need to do the manufacturing correctly. You need to get costs down and be competitive, but there's an area there where we can compete.
So it sounds like, from your perspective, we're really good at high-value engineering, solving problems, making things better. Ray, you're upstream from Steve. You manufacture wafer fabrication, or it's wafer fab. Does fab mean fabrication? Yeah. Okay, just explain in terms of, from your perspective, where's the UK strong?
Again, really engineering and innovation. I think we're very good at doing the hard stuff. Like the silicon carbide, we're very good at the prototyping, the developing, and the challenge that we have is the scaling, and the scaling at the price that the market, that is definitely the challenge that we have.
Yeah, it almost feels like you're getting through from the strengths, we're almost drawing out the weaknesses straight away. What's your perspective, Adam, on developing a market fit? Where are we strong? Where could we compete?
I think I very much agree with what's been said, and I think it's really about taking that expertise, and that's the design, the engineering expertise at whatever level, but really turning it into almost a critical mass of production to get that scale up. Because I think if you look at this at a global level, these technologies are being developed all over the world. They're being worked on at scale elsewhere. If the UK doesn't meet that scale, it's going to have to be imported from somewhere else. But to be able to really do that successfully, it really needs to look at how it can do that. Yeah, at a kind of a big enough scale with the full supply chain to support that. Otherwise, you're still going to be relying on other bits of the supply chain just to back and forth to feed the whole thing. Whereas you need a kind of fully connected supply chain really to build that at a scale that's needed.
Bhavik, can I bring you back in? Because have you got a vision, or the APC got a view particularly? Are we trying to do everything at scale, or are we better fitted into a niche?
We've got to look at this as a larger automotive problem, David, really. Without a supply chain, what is the car manufacturing industry of the UK going to look like? That's really what I'd like to make sure we get right. If we get the supply chain right, we keep our industry, we get that 60 to 70 billions of industry working very well for us. My worry is exactly as Adam just said, if we don't focus on the right sort of things and don't get the right bits, they can get it elsewhere. And if you go elsewhere, then the assembly line aspects start to get very affected. When supply chains move further away from the assembly lines, we've got a problem. And that's what we want to try to avoid. But there's great strengths, as Steve and Ray mentioned, in the UK that can do this. And it's a newish place for many players to play in. And we've already got a head start on that stuff. Adam's just explained how huge the market is. It's not about differentiation. We're going to need it everywhere. So why can't we develop something that serves our UK industry? So that's where I would like to see more focus on, is across the place, what we're good at, strengthen that, but where we need to understand how the dependency works, let's figure that out for the vehicle manufacturing assembly lines to be with us. That's the way I'd like to do this.
Okay, so it is ambitious, isn't it? Because we're building an industry almost from, not quite from scratch, but from expertise to scale. Yeah. And that allows us to keep the large-scale automotive industry building cars in the UK. Steve, scale's the gap, but turn that into smaller components so we can, how do we tackle, from your point of view, that huge elephant in the room?
Well, I think the first thing to say is we need to understand what the scale is. I think what we're not necessarily saying here is that we want to be taking on the large tier ones of the world that are making millions and millions of units. The UK is really good at that mid-volume type of manufacturing. So we've got to get the right scale. It's bigger than we're doing at the moment, but it's certainly within reach. And so making that transition to a slightly higher volume, let's say tens of thousands, hundreds of thousands of units, makes sense. And that's where we can compete.
Which parts of the market would that actually serve?
So this would be looking at maybe the more high performance vehicles, slightly niche vehicles. We've got a lot of disruption happening in the industry at the moment with new entrants. There's really a lot of opportunity when you start looking at that mid market. There's a lot of opportunity there for people to innovate, for people to disrupt. And that needs a manufacturing backbone to support it. And that innovation piece is where the UK does really well and where it can really compete.
It's certainly something that I've seen with some of the case studies I've done for Advanced Propulsion Centre, is going and seeing the aerial hypercar, and you kind of think that we all know how to make electric cars. Well, I don't, but the industry knows how to do it. But every one of the partners were saying, no, we're right at the beginning of this technology. There's huge room for expansion and growth and new technology. Sorry, Steve, you were going to say something.
I think there's also a part about protecting the industry that we have as well. The OEMs that we have in the UK do tend to be more niche, and they're unable on their own to compete with the larger OEMs when there's a lot of competition for these devices and this technology. So actually having that supply chain in the UK enables us to support our OEMs better, because they're not competing with the much, much larger groups of OEMs worldwide.
And Ray, does that fit with your thinking from Clas-SiC wafer fabs perspective?
Yeah, absolutely. Medium scale is what the UK is good at. There's some major challenges, like in the supply of silicon carbide wafers worldwide, because the demand is so high. It would be great to get in the UK that capability. EPI as well is an area that we have some capability on silicon carbide, but it's lower volumes. But I see no reason why we can't create that medium volume scale in the UK. We're leading in the prototyping, the rate and the speed that we do prototyping in silicon carbide devices.
So I understood from the APC Bhavik's work that the actual wafers, there's nobody making the wafers themselves in the UK, is that right?
That's
and so
correct.
you're kind of having to bring those in. Would it be useful to get that component built in the UK, or is it just makes more sense because of the lower margins to get it externally?
It would be really valuable where just now the amount of demand is higher than supply. So for the UK to really protect their supply, it would be ideal if we could get some UK sovereign capability in the silicon carbide.
So I guess that would be a competitive advantage, because if we can get them and nobody else can,
Exactly.
or everybody else is struggling and we can serve our own needs. Adam, have you got a perspective on this? You know, the missing pieces in the supply chain. I mean, I guess there's a lot missing, but where do we need to focus?
Probably the biggest missing piece is the substrate materials in terms of the UK capability currently. As we've kind of got examples here, even though there is a lot of capability at most of the other steps, even if it's not at scale yet. You know, in an ideal world, it would be great to have that capability in the UK from a supply perspective, but it is, you know, particularly if we look at silicon carbide substrates, there is a lot of challenge to kind of developing that, and I think in some areas we do have to accept that we've missed that boat with some of the technological development, at least from scratch. That doesn't mean kind of there can't be some kind of capability set up from kind of existing manufacturers, but you know, a lot of the in silicon carbide, a lot of the substrate capability comes from companies in the US at the moment that have been doing it for a lot longer and have scaled up much quicker. So to a certain extent, kind of, I guess also the value of these kind of studies that the APC is doing is looking at where those gaps are, to look at realistically which bits can we focus on. There are challenges there, but I think that still doesn't mean we can't look at the rest of the supply chain. Even when we talk about kind of more niche applications or performance applications, there is still reasonable scale. I think mid-scale is kind of, or the term used is a good way of putting it. This is still reasonable scale, and also not to forget that although a lot of UK-based companies might be more performance or niche kind of application focused, there is still a reasonably large mass market vehicle production in the UK today of petrol vehicles, mostly from foreign companies. If you look at kind of Nissan, Vauxhall and kind of Stellantis Group, Toyota have historically had production. There is a reasonable mass of this kind of more mainstream vehicle production in the UK. That's also going to need supplying if that or when that turns over to electrified production in EVs, and having that UK capability as well from a just supply chain security point of view is also really important, instead of relying on imported components. But I think again there is going to be a struggle to compete with the much larger scale mass market, as that becomes much more cost driven. But if we can look at those applications as well that require a bit, that are they're less price sensitive, but looking more at these custom or performance designs, then there's definitely a big opportunity there to make the most of the expertise.
I mean, just from my very early understanding of the sector, it does feel like it's the usual chicken and egg of we need the investment, we need the scale, which means the investment, and the investment needs the government buy-in, the industry buy-in, and de-risking the whole thing. Has anybody got a sense of, I mean, we need to communicate with government, we need to communicate with investors, but they're all going to be saying, too risky for us. Thank you very much.
I've got a comment on that. Well, if we talk about silicon carbide wafer fabrication, what I would say in Clas-SiC, we've de-risked. We've done a lot of the risky things. We've built a wafer fab from scratch. We've developed the technology. So we've done all the hard stuff. Scaling is just copying, repeating what you've already done. So that's what we need. We need help for investment to scale. We are in the right place at the right time with the market. We have people globally coming all round for fast prototyping, fast development. So we're in the right place at the right time, but it's funding for scaling is the challenge. And I don't think that's risky, because you could fill the capacity several times over.
Right. So it's not just, you don't just think it's the technology that's been de-risked, but it's the business case. Is that you could sell as many as you could make.
You could confidently be able to fill the capacity that you can create.
You're not able just to go and find a Dragon's Den and go in there and make your pitch? And
not yet.
I think that is exactly. So I think that's the important point, which is the technology. There are steps where we are excellent worldwide, David, and we just need to get over to a scaling aspect. There's something holding the scaling aspect in the UK. Let's figure that out with government. Let's figure that out with investors, what's going on. Which if a raised company is going to a situation where the bank says, oh, I do need a return on investment within a year or 2 years, which doesn't happen with a manufacturing system. It takes a long while to fit this line and start to make the money work its way through. There's a business model missing here, or some intervention missing here that we're missing the point of. So it's an investor's view of how they start to engage with this that we need to bring to more light. Even with the inverters, Steve, that you've got, we could be building these with manufacturing systems at mid-volume, but that takes money.
Yeah, absolutely, yeah. And in order to get, again, it's chicken and egg, in order to get the costs down to acceptable level, we need to invest in that manufacturing piece. I mean, there's no problem with demand. We know the demand's there. We've seen other economies investing, the US, Europe, Japan, China, they've all invested in this, and we're seeing the OEMs now forward buying devices because they see that they need them. It's not a problem about demand, it's about getting that long-term investment in the right place so that we can manufacture these devices and these products all the way through the supply chain.
So do you feel you've got a similar issue to Ray in terms of you've got the technology sorted, the business case is there, but it is the scaling. But
to some extent, and we have a project called Escape that was mentioned earlier, which is where we're leading, which has Clas-SiC and Exawatt in as well, which is all about trying to build up that supply chain in the UK. The reason we started that was because we didn't want to be reliant on non-UK economies for our really core technology. So that's starting to work, but that needs more investment in that supply chain. We also have another project that we're doing called Science, which is all about the scale-up of the manufacturing of the inverters. It's all about automation of the inverters and trying to build those in the UK at some scale, but at a competitive cost using automation. So those are really our problems, is making sure we've got the supply coming into us in a sustainable way, something that we can rely on, but also then actually manufacturing those products in a cost-effective way, doing that mid-volume manufacturing.
What's the next step? Let's break this into two bits. What's the next step for McLaren? What's the next key you need to unlock the next problem? And then the same question, but on a broader level, what's the next step for the industry?
Well, I think maybe if we take it from the other direction, I think we're seeing a huge push in the industry towards electrification, obviously, all around efficiency, but we're seeing a lot of that slipping a little bit at the moment. We're seeing a lot of investment needed by the OEMs to make these EVs work and get out into the marketplace, because they're realising how difficult this is. And so we need to be there and say, actually, we've got this sorted, we can make this work for you, we've got the technology there and ready now. So that's what we're trying to do. We're trying to get into that position where we have it ready for these OEMs to then take that on and take it forward.
And Ray, you're kind of earlier in that supply chain journey. What's the next pressing issue you want to, almost the immediate thing you want to get right now?
It's funding. It's funding because globally we're selling something that people want, so it's funding to capitalise for the UK and continue to grow the business. I mean, till I get funding, I'm almost slowing the business down. It's the wrong thing to be doing.
So that could be either investment or government support, or combination of the two. Yeah. And Adam, what do you think's the next step? What do we want to be doing in the next 2, 3, 4 months rather than years? What's going to get us moving forward?
I think, what kind of wanted to add to that, I suppose, is also on the kind of the funding side. A lot of this scale-up requires a lot of essentially capital investment in the first place. Getting particularly the device fabrication level, getting the equipment in, getting the facilities, and all that though. And it's a lot of it's a lot of upfront investment that I think the scale of investments going in elsewhere, it almost seems it might be putting people off at at least at a government level, just because it's such a large amount. But it's trying to convince people that it really is worth it, that there is such a big opportunity and it's so critical to the future of UK manufacturing in these sectors and electrification more broadly. You just have to look at a company like Wolfspeed, the biggest manufacturer of the silicon carbide materials. They're announcing in terms of investments in the US for this kind of mass market, mass scale stuff, and it's of the order of billions of dollars in each fab, and they're putting up 2 or 3 different manufacturing facilities for different stages of the production kind of over the last few years and going forwards. Okay, we're not going to be trying to compete exactly with that scale, but so it's not going to be maybe quite that much, but it's hundreds of millions, if not more, going into this, and convincing government, convincing investors, whichever form it looks like, to really make that commitment, I think is the real challenge. And kind of getting that message across that these are critical technologies for electrification, and I think, like kind of said earlier, it's kind of these are critical technologies they're going to come about anyway. They need to come about. It's just whether the UK is going to be part of it or whether we're going to be reliant on imports that potentially isn't as a reliable supply situation.
So it's kind of feeling like the next step is kind of get what we're doing here today, some awareness in the investor and the government communities, and then perhaps doing something like this in the City of London or wherever it is that these things happen. Bhavik, you got any last thoughts on how we start to come together as a wider community to make this happen?
Sure. I think the topics already raised is we're already good at some technologies. We already de-risked it. We've already got the design capability and the manufacturing aspect to go with it. And we need to unlock that from a mass scale-up investment aspect. And then the other side, I'd say, is the point brought up earlier, is as you go down the value chain, you realize we're actually not good at everything. And we do need to put our seeds in many ways just to give the innovation landscape the chance to help us out when we need to reach out on it, right? So if we're not making epi wafering, we're not the best at epi wafering. Should we be? Could we be? Because it'll help supply a Clas-SiC with the right things. Then from an epi wafer perspective, if we're not making the substrate, what does that do for us, and can we do something? So there are some interesting innovation companies in the UK who are willing to make a substrate. It's at a different level. It's not the same fabrication. It's not the same manufacturing process as done at mass level, which is what we don't want to compete with. But there are ways in which we could probably growth, seed, nuclear space capability that we could create, and therefore we need to also check the R&D side of things along the value chain. Because when we forget to do that, we get locked out with, we don't know enough about a topic, and we have to scale up our knowledge, say on battery technology suddenly, for an example, right? So if we get the investment right, we can mobilize it. The demand's there, growth's there. Companies are amazing. Who can do this for us? Let's put the money in R&D, make sure we don't have any blind spots. Sort out our blind spots. We may not be the best in the world and most economical in the world, but we will get there if we pose the problem correctly to say we need something cleverer than what's out there.
And obviously, it's going to take a collaborative effort. How do people get involved?
Yes, so pleased that McLaren has set up the Escape project with the partners, Clas-SiC, Exawatt, and more partners to be mentioned, Microchip, etc. So they've got a full end-to-end supply chain. When we say end-to-end, at least we're going from epi all the way through there. So we are here at the APC to create those collaborations, within the collaborations, see where the difficulties are. And hopefully Stephen and Ray saw that on the projects, where there's difficulties, we want to find out ways what's to unclog that and make this naturally work for the industry. That's what that is. And then where we need to talk about capital investment, we've got another arm called ATF, Automotive Transformation Fund. That also is a mechanism that can help as we go forward for partners. But effectively, we want to help that industry focus. What I think is missing, David, has been the understanding of power electronics, the understanding of a value chain, to understand where economically things make sense. So on our report, we created stacks of here's the value stack, and you can start to see actually what we're good at. There is 80% of value on the whole system in making an inverter. We are capable of delivering that in the UK. That's power modules, that's die manufacturing, that's inverter production, right? Even before you go to a wafers. So we can do something economically right, and that's clear. The silicon carbide demand is strong within our OEMs because we're high performance, high power vehicle manufacturers in the UK indigenously. We've got heavy goods vehicles, HGVs, they need to be operating at 1200 volts. We need some silicon carbide for that. We've got vans who need to be operated at high power. So there's something quite clear that we need to do. It's the language and the actionable items that we're trying to get through. So our insight report we have now available on our website helps that conversation, but we'd like to build where the missing gaps are in knowledge or in action or in communities. We want to build all of that and help everyone. So be good.
So if I could ask everybody who's watching this who would like to get involved in the power electronics industry to do something for me. If you go to the Advanced Propulsion Centre website, that's apcuk.co.uk. In the top right of the screen, there's a menu drop down and you can select contact. On there, fill in your details, and in the message, just say that you're interested in power electronics and give us some information about how you could help. And somebody from the APC will keep you informed of any future engagements that might be useful. So what we all want to do is keep this momentum building, go from discussions to decisions to action. And to do that, we're going to need collaboration. And it's going to take industry, government, researchers and investors to all come together to make this happen. So I'd like to say thank you to the Advanced Propulsion Centre for bringing everybody together today. It's a very valuable opportunity to begin this collaboration. Thank you to the panel. Thank you to Steve Lambert from McLaren Applied, Ray Hindman from Clas-SiC Wafer Fab, Adam Dawson from Exawatt, and Bhavik Shah from the Advanced Propulsion Centre. And thank you all in the audience for coming along today, and everybody that's watching online. So let's keep that momentum going, and let's see the UK build a world-class automotive power electronics industry. Thank you.
Thanks for listening to the end of the panel. We hope to do more of these kind of events, so please register your interest or get in touch with the APC via our website. See you next time, and goodbye from The Road to Net Zero.